Okay, welcome back, Mr. Nolde here. Today we're going to talk about this fancy little word, PEMDAS. So what does PEMDAS stand for, right? This is an acronym. It stands for parentheses, exponents, multiply, divide, and we do this left to right, add and subtract, and we do this from left to right. So if you can remember this, you can solve almost any order of operations problems that we're going to look at. One of the things you might have learned earlier in grade school is an acronym or a mnemonic device to remember this acronym. So I learned, please excuse my dear Aunt Sally, right? Sounds funny. Maybe you learned it as purple eggplants make delightful afternoon snacks. However you remember it, just remember that this is the order of operations that you have to follow all the way through school. This is the order of operations that your calculator will use when you type an expression into your calculator. Okay, so maybe you've been wondering about order of operations, maybe not. Maybe you just want to get those questions you see on Facebook answered accurately. But this is what we're going to talk about today, order of operations. So we are remembering that we have this acronym, PEMDAS, which stands for parentheses, exponents, multiply and divide left to right, and then add and subtract left to right. So a lot of people think that you have to multiply first, divide second, add first, subtract second. So here's a common one that I will see a lot of people kind of get mixed up on. 4 squared minus 3 times the quantity 2 plus 1. So a lot of students will be, okay, I know I have to do exponents first, right? That's in my PEMDAS. And then they'll go ahead and say, and I got to do parentheses first. So that's 3 times 3. One of the biggest mistakes I will see is students will go to 16 minus 3. This is wrong. They'll say, 13 times 3. Well, that equals 39. That is not the correct answer. So one of the things that you need to remember is you don't just go through left to right. You go and multiply first. So I'd have 16 minus 9. And 16 minus 9, well, that equals what? 7? So 16 minus 9 is 7. So we go ahead and say that this is our final answer. The other thing you might notice is when you solve these problems, when you simplify them and do them step by step, you end up making what looks like a funnel. And I think this is why a lot of grade school teachers call these funnel problems. So funnel problems just mean order of operation problems. So there's a first example. Let me give you one that looks a little bit more challenging. All right, so here's another example. I have 10 times 3 in parentheses plus 7 times 5 plus 4 in parentheses. So one of the first things I will tell students is try to identify how many terms you have here. So I'm adding here. So here is one term, and this is a second term. So there's like two different pieces that need to be simplified before we can add them together. So let's go ahead and do this. So in the parentheses here, I have 10 times 3, which is 30. I'm not going to multiply by, I could distribute, but if I'm just doing a regular problem, I'd have 30 plus 9 times 7, 7 times 9. So the next step would be to multiply here. So we have 30 plus 63. Last step, add the 30 and the 63, and we end up with 93. So our final answer to this problem is 93. So remember, identify if you can how many terms you have that you're adding together, because then you kind of think about these as simplifying them term by term so that you can simplify the problem. And again, here is our funnel, right? So let's look at one more quick example and then I'll let you go. Okay, so this example has a numerator and a denominator. And one thing to remember when you have numerator and denominator is these are not written in here, but the numerator and the denominator can be simplified separately, right? The division bar functions as a symbol of inclusion. So when I look at my numerator, I see that I have 3 times 20 plus 2 times 20. That whole thing, that sum, multiplied by 6 minus 20. So I have in the top 2 terms. This minus sign tells me this is one term and this is a second term. So I'm going to go through and simplify this. So 3 times 20, that gives me a 60. Plus, what is 2 times 20? Oh, that gives us a 40. Now, we still haven't done anything with multiplying by 6 on the outside, and we also have a minus 20. And because the fraction bar functions as symbols of inclusion, I can go ahead and say 10 squared in the denominator. That gives me 100. All right, good enough. So let's see, what is 60 and 40? 60 and 40, well, that gives us 100. Whoops, not 1,000. 100 times 6 minus 20 all over 100. So I haven't done anything yet with the denominator because I have to simplify the numerator now. So what is 100 times 6? I'm going to have to bring this up here. 100 times 6, well, that would give us 600. And minus 20 all over 100. So 60 minus 20 ends up giving us 580. And 580 divided by 100, well, that is 5.8, right? Dividing by a power of 10, so we're moving the decimal 2 places, so that becomes a 5.8. So one thing to make clear is that whatever we're starting with, every statement that we write is equivalent to the statement above. So this equals this equals this equals this. So until you get to the end, you want to write equivalent statements. That way you don't forget anything. Sometimes I see students just break out and do parts of it, but then maybe they forget this minus 20. So you want to be very careful to write down equivalent expressions all the way. So hopefully you got some value out of that. If so, share this with a friend or a classmate. You're not going to see a lot of these once you get to higher level maths, but it's still a very important skill that you need to keep up with. So make sure you're doing your homework. Remember, the only way to learn math is to do math. It's not a spectator sport. Until the next time, this is Mr. Nolde signing out.